All right, guys, so the next transformation that we're going to look at is rotations. So remember that a rotation is just a turn. Now, something that's a little bit different about this is that we're going to use coordinate notation for these rotations. I'm just going to demonstrate that for you as we go through our examples. But something else that's a little bit different is that we're going to have to look at the rules for rotating, and we're going to rotate 90 degrees, 180 degrees, and 270 degrees. Now, we'll also turn to the right and we'll also turn to the left. Okay, so turning to the right is going to be clockwise, which actually this seems backwards, but it's going to be a negative. So if we turn negative 90 degrees, it's going to be to the right. But if we turn a positive 90 degrees, it's going to be to the left. Okay, so if you can remember that that the if you'll remember that the quadrants they're labeled like going to the left, so that's probably going to be helpful to kind of help you remember that positive is to the left, negative is to the right. So if we rotate a figure from the right, see 90 degrees clockwise, so negative 90. All right, so our rule, we're going to have to look at these first because this is going to be super helpful. It's a little bit more challenging to look at these, to rotate it and then look at them. So when we rotate clockwise and it's a negative 90 degrees, then you go from XY, this is going to flip. The X value becomes negative. So you're going to flip the coordinates, and you're going to make the X value the opposite sign. So if you are going to turn left 270, guess what? That's like turning to the right, to the right, 90 clockwise, negative 90. So negative 90 and positive 270 are going to have the exact same rule. And then whenever you rotate 180 degrees, okay, that's going to stay the same whether you're going to go positive 180 or negative 180. It ends up being the exact same. You just change the sign of X and Y and they stay in the same order. So it's just the opposite sign of X and the opposite sign of Y. Okay, so they stay in the same order. You're just flipping the sign. So same thing with the counterclockwise with 180. It's the exact same because it's 180 is kind of the middle ground, I guess. And then the last one is going to be turning to the right, negative. This is going to be negative 270, so it's going to be clockwise to the right. So this is going to take it, and you're going to switch the X and the Y again, and you're going to take the opposite sign of the Y. So you flip flop there. So a lot of this is going to be is just kind of backwards. So like you just take opposite signs with 180, the 90 and the 270, you flip the order, and then one of them you're going to take the opposite sign. So if I turn to the right 270, so negative 270 degrees, that's the same thing as turning to the left positive, that's a positive, the counterclockwise, positive 90. So that's going to go here as well. So do you have to memorize this whole table? Nope, you really don't. If you memorize one side of it, then you'll know the other side based on whichever way you're turning. So if you know that negative 90 is the same thing as positive 270, then when I say rotate this figure a positive 270, then you'll be able to know. Okay, so so when I say rotate this figure positive 270, you'll know that that's really negative 90. So as long as you know one side of it and you know which ones correspond, there's gold. So let's take a look at some of these. So we're going to rotate the rectangle EFGH 90 degrees about the origin. So that's how you say those. So if I were to write this in coordinate notation, it's going to be a rotation 90 degrees about the origin, figure EFGH. So this is a rotation 90 degrees about the origin, E, F, G, H. So that origin piece is really important because you probably haven't seen this before, but we're going to actually rotate about a point. So it's really important that you know what point you're turning around. So what I'm going to do, so I've already listed out the points there, those locations. So we're going to use, we know it's going to be, it's a positive 90. So we're going to be turning to the right, to the left 90. So if I refer back to my rules, that's going to flip the X and the Y and make the Y the opposite sign. So I'm going to write this little rule up here so that I can remember it. All right, so I'm going to flip the X and the Y. So if I were to flip the X and the Y here, that's going to be 3, -2. But then I'm going to make this -3, -2. So this is going to be G prime. So I flipped the X and the Y, then I made the Y the opposite sign. Same thing with H. I'm going to flip the X and the Y, and then make the Y coordinate that's now the X coordinate for my new point negative. And this is H prime. So it flips all the way right there. So you can see it's going to turn like this to the left. So F, we're going to flip the X and the Y. And I'm going to make the Y coordinate negative. But I still plot it the exact same way. That's F prime. And then E prime, I'm going to flip them. So 6, -8. And then I'm going to take the opposite sign of the Y value. So -6, -8. All right. So this is on for this transformation. So you can see it's turned to the left and it's turning about the origin. Okay. So just flip. And so that's why it's really important that you think about and know these rules so that you can apply them and not have to try to turn it on your own. Okay, so this time we're going to rotate the figure 180 degrees. So positive or negative, it ends up being the exact same. About the point 2, -1. So 2, -1 is right here. So what we're going to do is we're going to pretend that this little spot here is the origin. Okay, and so I'm going to go over 1, up 2. So technically, the point is 3, 1. But if I were to really label this like my new point as the origin, that is 1, 2. Because I'm going over 1, up 2. So like if I were to name A again from this point right here, I'm pretending this point right here is the origin, that would be like 1, 2. Then I'm going to make -1. I'm going to flip this. I'm just going to flip the sign. So it's -1, -2. So I'm going to go left 1, down 2. So this is going to be A prime. So you can also count it like you are taking it and you can also label it such that you can just count over and up if you would like to, if you know that. So like C is over 5 and up 2. So I'm going to just make that the opposite. I'm going to make it -5 basically and -2. And that's C prime. Now then, B is going to be a little bit more challenging. So I'm going right 1, 2, 3. I went right 3 and up 7. So I'm going to do the opposite signs of those. I'm going to go left 3 from my point, from my rotational point, and then I'm going to go down 7. If I were to write this in coordinate notation, this would be a rotation 180 degrees about the point 2, -1, figure ABC. So that's the coordinate notation there. All right, and so for our last example, we are going to rotate the triangle XYZ -270 degrees. Okay, so remember, I'm going to write the coordinate notation is negative 270. And this is going to be about the origin. I did not tell you that. And then it's going to be figure X, Y, Z. So that is the coordinate notation. So I'm going to rotate the triangle negative 270. So that's actually going to be to the right. And so once I do that, so the rule for negative 270 is going to be XY. And then remember, you flip the order and you change the sign of Y. So I'm going to, so I have X, the pre-image is just XYZ. And so I have 1, negative 3. So I'm going to flip those. So it's going to be negative 3, 1. And then I change the sign of the first coordinate. So it ends up being a positive. So I'm going to move it. So X prime is going to be right here at 3, 1. And then Y is at 7, 1. So I'm going to flip that order. So this is going to be 1, 7. And then I make the Y coordinate, or the now the X coordinate, the opposite sign. So it's going to be negative 1, 7. That's going to be Y prime. And then Z, I'm going to flip the order again to get Z prime. So negative 6, 4. But then I change the sign of the first coordinate, which is the negative 6. So that makes it 6, 4. So here is Z prime. So my image is going to look like that. So you can see that it's turned to the left 90, and it's also turned to the right 270 degrees. So I would say the hardest part is going to be when you are rotating about a point. So you're going to move your origin over to your new point, and then you're going to either calculate over and up and changing that way, or you can name new points from your pretend origin. So whichever method is going to work best for you. It's just that I feel like is the most challenging. So I want you to find something that works best for you and not let me tell you how to do it. But those are the two options that you have working from there. So rotating is just a turn. Remember, positive is going to be to the left and negative is turning to the right. And remember that 90 and 270 kind of line up together, and then and vice versa with positive and negatives. And then 180 is just the same on both sides. So it doesn't really matter. It would be a great idea for you guys to keep these rules handy until you kind of get them in your head to be able to rotate these figures. That's it.